Hello students, a very good morning to all of you. So let us continue with the next sum from practice set 8.1, question number 1, sub question number 4. The question is, construct the following quadrilateral of the given measures. Construct the quadrilateral LMNO such that length of segment LM is equals to the length of segment LO, that is equals to 6 centimeters. Length of ON is equals to length of NM, which is equals to 4.5 centimeters, and length of OM is equals to 7.5 centimeters. So as the thumb rule suggests, first we will construct the rough analytical figure so that we get the clarity of the given quadrilateral, right? So we are going to draw the quadrilateral LMNO. So let us mark the measurements. Length of LM is equals to length of LO, which is 6 centimeter respectively. Length of ON is equals to length of NM is equals to 4.5 centimeter. Now if you observe the last pearl, length of OM is not drawn. So we'll draw first OM here by joining point ONM, we get 7.5 centimeter. So first we will draw the side LO of 6 centimeters. Mark it as L and O. We have got 2 points out of 4. 2 other points M and N, we need to plot them. So let us focus on the point M first. Point M is at a distance of 6 centimeters from the point L. So on the compass, we will take a distance of 6 centimeter, place it on the point L because we are constructing side LM. Okay, mark the arc of 6 centimeter, right? One more thing which we can observe from the analytical figure is point M is at a distance of 7.5 centimeters from point O. So again we will take a compass, make a measure of 7.5 centimeter, but this time we are placing the compass on the point O and we are making an arc over there. Wherever these two arcs are intersecting, that is your point M. So with the help of a scale and a pencil, we will join ML and MO and mark their measurements as 6 centimeter and 7.5 centimeter respectively. Now students, the fourth point which is remaining is point N. Now look at the figure which we have drawn. N is at a distance of 4.5 centimeter from the point M. So again we will take a compass, make a measure of 4.5 centimeters. Remember we are marking MN. So compass will be on the point M and an arc of 4.5 is marked. Now we will mark out ON of 4.5 centimeter again. But this time the compass is on the point O. Wherever the arc are intersecting, that intersection point will be your N. So on a simple note, join ON and join NM. Alright students, with this our construction of the quadrilateral LMNO is completed. Now let us move ahead with the next concept, very interesting, that is the types of quadrilateral. There are basically 6 types: rectangle, square, rhombus, parallelogram, trapezium, and a kite. These 6 are types of quadrilateral. So we are going to focus on the word rectangle first. Now, which quadrilateral can be called as a rectangle? Let us see the definition first, students. If all angles of a quadrilateral are right angles, it is called as a rectangle. Okay, so let us have a quadrilateral ABCD. If you observe the figure carefully, the angles are marked with a box that indicates it is a 90-degree marking, right? So in the quadrilateral ABCD, measure of angle A is 90 degree, measure of angle B is also 90 degree, measure of angle C is 90, and measure of angle D is also 90. So that means all the angles of our quadrilateral are 90 degrees. Yes, which can also be called as right angles. So therefore, the quadrilateral ABCD is a rectangle. That's a very simple concept. Any quadrilateral where all the angles are right angles is called as a rectangle. Now every rectangle has few properties with it. First one, the opposite sides are congruent. Let us observe the opposite sides in our figure ABCD. Correct. If you observe side AB and side CD, they are opposite to each other, so they are congruent, right? So we will write that side AB is congruent to the side CD. Similarly, another two opposite sides are present with us, that is side BC and side AD are congruent to each other. Correct. Another property of a rectangle is the diagonals are congruent. What do you mean by diagonal? Correct. A segment which joins two opposite vertices or points. Like for example, if I join A and C, the segment AC is the diagonal. If I join point B and D, then segment BD is a diagonal. So they are congruent to each other. Third and important property is the diagonals bisect each other. As you can observe, the two diagonals are bisecting each other. Bisect means bi means two, sect means sections, right? So diagonal AC is making two equal part of which diagonal BD. Okay, so they are intersecting at the point O. So let us name them. So segment OD is congruent to segment OB. As they are congruent, their measures are also equal. So we can also say that segment OD is equal to segment OB. These two equal parts are half of the total length of diagonal DB. Correct? On the same note, we can make a point that segment OA is congruent to the segment OC. Again, the property that diagonals bisect each other. That is, segment OA is equals to segment OC is equals to half of segment AC. Clear, students? So these are the three properties of a rectangle. That is, first property, the opposite sides are congruent. Second property, diagonals are congruent to each other, or you can say they are equal. Third property, diagonals bisect each other. But where do we observe rectangle shape in our daily life? If you observe a television, yes, the opposite sides are congruent to each other and they are 90 degrees. Yes, correct. So that means a TV is an example of a rectangular shape. If you observe the billiards board, this also presents a rectangle with opposite sides equal or congruent, all the angles of 90 degree, right? So I hope you all would have understood the concept of a rectangle. Okay, so as we have got the properties of a rectangle, let us continue with the practice set 8.2 question number 4. The question is, if diagonal of a rectangle is 26 centimeter and one side is 24 centimeter, find the other side. So first of all, to solve this question, we will take the help of a rectangle. Okay, so we will draw a rectangle and name it as ABCD. You can also name it as PQRS. Okay, as per your convenience. Because we are assuming the rectangle in this particular question. So we will start the solution from the word let. So let quadrilateral ABCD be a rectangle, right? In this rectangle, the diagonal is 26 centimeter. So let us have the diagonal AC with us of 26 centimeters, right? And one side is 24 centimeter. So the diagonal AC is 26 centimeter. The length of AC will be 26 centimeters respectively. Now the length of one side is 24 centimeter. Now 24 is just slightly smaller than 26. Okay. So we will mention the bigger length of the rectangle to be 24 centimeters. So let BC be 24 centimeters. Correct. Now we want to find the other side. Now which other side is remaining in the rectangle? AB. Correct. Now if you observe students, A, B, B, C and AC, if you combine all of them, are we making a rectangle में से एक triangle बन गया हमारा? Yes, we are making a triangle into it, right? Correct? Because AB, BC and AC together they are making a triangle. And moreover, if you observe the angle over there, it is 90 degrees. So that means in triangle ABC, angle ABC is 90 degrees. And whenever you have a right angle triangle, in that right angle triangle, if you know the measurement of two sides, you can easily find the measurement of the third side using Pythagoras theorem, right? Correct. So in our triangle ABC, AC is the hypotenuse. AB and BC are the side 1 and side 2, right? So let us write the Pythagoras theorem for triangle ABC. AC is the hypotenuse. So length of AC square plus length of AB square plus length of BC square. We have got this statement from the Pythagoras theorem. Now on the next step, we will substitute their respective values. What is the value of AC? 26 centimeters. So we will write 26 the whole square because it is AC square, right? Length of AB, we have to find it out. So keep it as it is. Length of BC square, that is 24 the whole square. Now, let us find the value of 26 square first. That is 2676. AB square will remain as it is. 24 square is 576. As we want the value of AB square, so keep it aside. Okay, 576 will become minus 576 when it goes on the other side. Correct. So how will you write that? 676 minus 576. When you subtract them, you get the answer 100. Now AB square is 100. So to remove the square, we will take square root. So length of AB will be 10 centimeters by taking square root on both the sides. So you've got the length of AB. Now the question was in the form of a statement. So we will conclude our answer with the statement that length of the other side is 10 centimeters, and we'll keep the final answer in a beautiful box. Alright. So with this, we complete the sum number 8.2, question number 4. Now let us continue with the example. P is the point of intersection of the diagonals of rectangles A, B, C, D. If length of AB is 8, then length of DC is what? Length of BP is 8.5, then length of BD and BC is what? So to make the question and the solution very simple, what we will do is we are going to consider a quadrilateral, that is ABCD, as a rectangle first. Now let us mark the values. Length of AB is 8 centimeter, length of DC is unknown, length of BP is 8.5 and length of BD is unknown. Now P is the point of intersection of diagonals of rectangle ABCD. So let diagonal BD and diagonal AC intersect in the point P. Length of AB, which is 8 centimeters. Length of DC, we don't know. So we'll take a question mark for that. Length of BP is 8.5 and BD we have to find it out. Now let us focus on it, students. AB and DC are two opposite sides of a rectangle. Yes. So if AB is 8, then DC will also be 8 centimeters. So let us write that into statement form. Opposite sides of a rectangle are congruent. Therefore, length of DC is equals to length of AB, which is 8 centimeters. Simple and clear. So let us write the answer in a box. That marks the first part as a solved one. Question number 2. Length of BP is 8.5. Now look at it very carefully, students. BP is the half part of the diagonal, right? And we need to find the length of BD. Observe BD. BD is the length of full diagonal. So when we were studying the properties, we have learned that BP will be half of the total length BD, right? Because diagonals bisect each other in a rectangle. So we will state diagonals of a rectangle bisect each other. Therefore, length of BP is half of length of BD. Length of BP is 8.5 is equals to, sign as it is, half from the above equation as it is, length of BD as it is. Now we want the length of BD segment. So we will shift 2 on the left side. But observe, students, 2 is dividing on the right. When it goes on the left, it will become multiply. So length of BD will be equal to 8.5 into 2, which is very simple calculation, that is 17 centimeters. And with this, we complete this particular example question. All right. Now, we will find out the length of BC also. All right. So the question is not completed yet. Now, length of BC. Observe the side BC. Ask yourself, is BC a part of a triangle? Yes. Which triangle? BDC or BCD. Yeah, correct. Now in the triangle BCD, angle BCD is 90 degrees. Perfect. Do we know the values of two sides of that triangle? Yes, sir. We know the length of side BD and we know the length of side CD also. So using Pythagoras theorem, we can easily find out BC. So let us use the Pythagoras theorem that hypotenuse BD square is equals to BC square plus CD square. By Pythagoras theorem, substitute the values. BD square What is the value of BD? 17 square. BC square as it is. What is the value of CD? 8 the whole square. Let us find the value of 17 square, which is 289 first. BC square as it is, and 8 square is 64. Now student, BC square will become equals to 289 minus 64. That gives you total 225. But remember, at the last step, when there is a square, you have to take square root on both the sides. So BC will be equal to 15 centimeters. So with this part, we complete this particular sum also. Now let us go with practice at 8.2, question number 1. Draw a rectangle. That means we have to construct a rectangle ABCD such that length of AB is equals to 6.0, that is as good as 6 centimeters. Length of BC is 4.5 centimeter. So let us have the analytical figure first. Name it as ABCD, where AB will be the base. What is the value of AB? 6. So we'll mention it as 6 centimeters. What is the value of BC? 4.5. So BC is 4.5 centimeters. So drawing a rectangle, we will first draw the base AB of how many centimeters? Correct, 6 centimeter. Then we all know we will use a protractor to mark an angle of 90 degree, because all the angles of a rectangle are 90 degree, right? So we'll draw a 90 degree line over here. Then we will place the protractor on point B. Again we will mark 90 degree. We draw another line. Now students, what is the value of side BC? 4.5. And if I'm not wrong, if side BC is 4.5, then its opposite side AD will also be 4.5 only. Correct. So we'll take a measure of 4.5 centimeter on the compass. Mark the arc of 4.5 centimeter from the point A, name it as D, and then from the point B, name it as the point C. Clear? Now we have got point C and point D clearly. We will join them with the help of a scale, and if you observe carefully, our rectangle ABCD is constructed successfully. Okay, students? Fine. Alright, students. As we have discussed about the rectangle, now it is a turn to discuss about a square. Now, which quadrilateral is called as a square? If all sides and all angles of a quadrilateral are congruent, means their measurement values should be same, then that quadrilateral is called as a square. For example, let us have a quadrilateral ABCD. Okay, I'm saying the word quadrilateral. Let us look at the sides. If I say all sides are congruent, for example, if AB is 4 centimeter, BC is 4 centimeter, CD is 4 centimeter, AB is also 4 centimeters, then can we say that all the sides are equal and congruent? Yes, sir, absolutely. So we will mark them with the two strike, that is all four sides of the quadrilateral are congruent. Okay, so side AB is congruent to the side BC, is congruent to the side CD, is congruent to the side AD. Now let us think about all the angles. If you observe it carefully, all the angles in this particular quadrilateral, right? That is angle A is congruent to the angle B, is congruent to the angle C, is congruent to the angle D. Now what is the measure of all the angles first of all? So that is not at all mentioned, right? Correct. So measure of angle A is equals to the measure of angle B is equals to the measure of angle C is equals to the measure of angle D, which is 90 degrees, right? Now, if all the measures are 90 degrees, they are all congruent to each other. Yes. So we have seen two conditions for this quadrilateral. First condition, all the sides were congruent. Second condition, all the angles were congruent, that is 90 degrees. How it is possible? As sum of all the angles is 360 degrees. Clear, students? Okay. So therefore we say our quadrilateral ABCD is a square. Okay. Perfect. Now let us look at the properties of a square. Property number 1, diagonals bisect each other. So diagonal AC and diagonal BD are bisecting each other at the point O. So let us mark them with the three strikes, that length of OD is equals to the length of OB. And similarly, length of OA is equals to the length of OC. Second property, diagonals are perpendicular to each other. So we can say measure of angle AOB is 90 degree. Similarly, you can say measure of angle BOC, measure of angle COD, and measure of angle AOD. That is also 90 degree. Third property, the diagonals are congruent to each other. So we can say segment AC is congruent to the segment BD. Correct? So three properties we have learned regarding diagonals of a square. Diagonals bisect each other, they are perpendicular to each other, and they are congruent to each other. The fourth property, the diagonal bisect the opposite angle. Now if I remove the diagonal BD, we can see clearly diagonal AC is there. In the diagonal AC, angle A is divided into two equal parts. That is angle DAC as the first part and angle BAC as the second part. Similarly, angle C is also divided into two equal parts. Let us name them angle DCA and angle BCA. Alright, students? Perfect. On the same note, we can also divide angle D as ABD and CBD. So same way we can divide angle B and D also. Alright. Where do we see the square in our daily life? A carom board with all the sides equal to each other and all the angles of 90 degree. So it is a square shape. A chocolate cut into a shape of a square. All the sides are congruent to each other. Wow, fantastic. All the angles are 90 degree. Correct. Now with this, we go with the practice set number 8.2. Question number 6. Find the length of a diagonal of a square with side 8 centimeters. So to understand the question carefully, we will assume a square PQRS. As we are assuming it, we will start our sum from the word let. Let quadrilateral PQRS be a square of side 8 centimeter. As we all know, all the sides of a square are congruent. So all the sides will measure 8 centimeters. Now find the length of diagonal of a square. You can take diagonal PR also, or you can take diagonal QS also. As in this case, we are taking the diagonal PR. What is its length? We have to find it out. Now always ask yourself, if I draw the diagonal PR, our square is divided into two triangles. Correct. Observe the triangle PQR. Is it a right angle triangle? Yes, sir. Why? As angle Q is 90 degree. Okay, because it is a square, तो वो square का ही angle है Q. So PQR is 90 degree. And if you have a right angle triangle, you know the two values of two sides. We can find the third side using Pythagoras theorem. Correct. So length of PR the whole square will be equals to length of PQ the whole square plus length of QR the whole square. By Pythagoras theorem, let us substitute the values. We want to find PR, keep it as it is. PQ the whole square, that is 8 square, plus 8 square, as they are side of the rectangle, they are congruent. 8 square is 64 and 8 square again is 64. Now 64 plus 64 is 128. We have to take square root on both the sides. So it will be root of 128 because 128 is not a perfect square. So it will be kept under a root sign. But students, if it is not a perfect square, we can write down 128 as 64 into 2. I'll repeat. 128 is not a perfect square. So we will write it down as 64 into 2. 64 का square root is 8. Correct. So 64 का square root is 8. The remaining part of root 2 will come down as it is as root 2. Okay, I'll repeat once again. Square root of 64 is 8 into 2 will remain under the root sign, will be root 2 only. So we have found the length of the diagonal as 8 root 2 centimeters. Correct? Alright. Okay, students. Now we will go with the next part, that is practice set number 8.2, question number 2, which is draw a square WXYZ with the side 5.2 centimeter. So first of all, we will draw a rough analytical figure. As it is a square, all the sides are equal, that is 5.2 centimeters, right? And all the angles are 90 degree. So first of all, draw the base WX of 5.2 centimeter. Please mark 5.2 very carefully because it is a very small value, that is 5.2. Okay, so you have to be a bit sharp while marking 5.2. Name it as WX. जैसा हम quadrilateral draw करते थे same way we are drawing a square. 2 point बाकी है हमारे, right? Correct. W has an angle of 90 degree. So keep a protractor on the point W. Mark 90 degree. Draw the line segment. Same process we will continue on the point X. Mark 90 degree with the help of a protractor. Draw the line segment. As we all know, the distance between W and Z is 5.2. So we'll mark and measure an arc of 5.2 centimeters. Keep it on the point W and mark our arc as the point Z. Similarly, we will mark the same distance of 5.2 from point X, marking the point Y. Now, Z and Y are clearly visible, so just join them using a scale and a pencil. And we complete our square WXYZ. Okay, students? Kind of a simple sum. Very simple, right? Start with this sum. Okay, so I hope you all have completed your work. So I'll see you in the next lecture, everyone. Thank you so much. Have a wonderful day ahead. Take care. It was a wonderful experience to teach you all. Thank you so much. Bye bye.